There are two questions given here, but in exam you can choose either first one or second one. Let us discuss both. So first we will discuss question A. Here the questions write two important characteristics of equipotential surfaces. So let us discuss the important characteristics of equipotential surface. So the first characteristic is potential has same value. Potential has same value at all points of the surface. And the second characteristic is electric field is normal, again at all points of the surface. Third one is work done in moving any charge between any 2 points is 0. So work done in moving any charge between any 2 points is 0. So these are all the characteristics of equipotential surfaces. Now let us discuss question B. Here the question is the thin circular ring of radius r is charged uniformly so that its linear charge density becomes lambda. And they are asking us to derive an expression for the electric field at point P at a distance x from it along the x-axis of the ring. And they are asking us to prove at lowest distance x greater than r, the ring behaves as a point charge. Let us take the x-axis, y-axis and z-axis. A thin circular ring of radius r is charged uniformly so that a linear charge density is lambda. So they are asking us to derive the expression for the electric field at point P. So let us take this is point P and the length is x along the ring. So here we have dV and this angle is theta. Here we have dE and dE sine theta, right? So this is our digit. So now let us form a triangle. Yeah. So electric field due to any element point charge point P, we can write dE, which is equal to 1 by 4 pi epsilon naught into dQ by r square plus x square. So this electric field at the point P will have two components. One in the vertical direction and the other one is in the horizontal direction. See here dE cos theta, which along horizontal direction, and dE sine theta along vertical direction. So the vertical component will cancel out the effect of each other due to the presence of the diametrically opposite element. So only the horizontal element will exist. So the horizontal component of the electric field will survive at the point P here. So now we can write dE cos theta, which is equal to dE into x divided by square root of x square plus r square. So hence the total electric field will be E equal to integration of dE cos theta. So we can write 1 by 4 pi epsilon naught integration of dQ divided by x square plus r square into x divided by square root of x square plus r square. If we simplify this again, we get 1 by 4 pi epsilon naught into x divided by x square plus r square the whole part 3 by 2 integration of lambda into dm. So we have 1 by 4 pi epsilon naught into x into lambda divided by x square plus r square the whole part 3 by 2 into 2 pi r. So we have q divided by 4 pi epsilon naught into x divided by x square plus r square the whole part 3 by 2. So we know that theta, which is equal to lambda into 2 pi r, so which is equal to total charge of the ring. So the field is directed along the axis when x is much larger than r. So we have the condition x is greater than r, much larger than the r. So we have E equal to theta by 4 pi epsilon naught into x divided by x square the whole part 3 by 2. So finally we have E equal to 1 by 4 pi epsilon naught into q divided by x square. So at large distance x is greater than r. So the ring behaves as a point charge. Now let us discuss our question. So in that we have two questions A and B. So we'll discuss A first. Here the questions state Gauss law on electrostatic and derive an expression for the electric field due to a long straight line uniformly charged via linear charge density lambda at a point lying at a distance r from the wire. Okay. So Gauss law, what is Gauss law? This Gauss law states that electric flux through a closed surface is 1 by epsilon naught times of the charge enclosed by the surface. So we get right IE which is equal to Q divided by epsilon naught. So now according to the given information, let us take the uniformly charged wire.
I need sway.
Let's take the length of the wire is L and
This
DS1 and this is the radius R and this is DS1.
this is 3.
So this is uniform thin wire. So let the charge be uniformly distributed on a wire. So we have taken the charge here. So let us write phi which is equal to d phi which is equal to integration of S1 E into ds1 plus integration of E into ds2 plus integration of E into ds3. So now we have the integration of S1. So the value of ds1 E into ds1 into cos 0 degree plus integration of E into ds2 cos 90 degree plus integration of E into ds3 cos 90 degree. So we have E into ds1 so which is equals to E into 2 pi r L. Now we are going to substitute this in the Gauss law. Q by epsilon naught which is equal to E into 2 pi r L. So we have E equal to Q divided by 2 pi epsilon naught Rn which is equal to 1 by 2 pi epsilon naught into lambda by r. So from this we can write E equal to lambda divided by 2 pi epsilon naught r. So this is the answer for the given question. Now let us discuss question B. Here the question is the magnitude of electric field in a region varies with the distance r as E equal to 10r plus 5. The question is by how much does the electric potential increase in moving from point r equal to 1 meter to a point at r equal to 10 meter. So they have given the magnitude of the electric field. So E which varies from 10r plus 5 and the RS varies from 1 m to a point at r is equal to 10 meter. So now we are going to find how much does the electric potential increase, right? So let us take E equal to 10r plus 5. So we have dV which is equal to minus E into dr. So if we integrate on both sides, we get minus integration of E into dr. So we know that the value of E is 10r plus 5. So we get 10r plus 5 into dr. So if we integrate this, we get V. And if we integrate this one, the limits from r equal to 1 to 10. So we have 10r plus 5 into dr. So V equal to minus 10 into r square by 2 and the limits from 1 to 10. plus 5 into R, the limits from 1 to 10. If we simplify this, we get minus 5 into 100 minus 1 plus 5 into 10 minus 1. So we have minus 5 into 99 plus 5 into 9. So we get V equal to minus 540 volt. This is the increase in the electric potential.